Foundations of Amateur Radio. The other day I received an email from Frank, Kilo 4 Foxtrot Mike Hotel, asking me about an idea I'd worked on some time ago, namely the notion that I might monitor solar flux at home using a software-defined radio. At the time I was attempting to get some software running on my PlutoSDR and got nowhere fast. Before I continue, a PlutoSDR, or more formally an ADALM Pluto Active Learning Module by Analog Devices, is both a computer and a software-defined radio receiver and transmitter in a cute little blue box. I've talked about this device before. It's an open design, which means that both the software and hardware are documented and available straight from the manufacturer. Out of the box, it covers 325 MHz to 3.8 GHz. You can connect to a PlutoSDR using USB or via the network, wireless or Ethernet, though I will mention that neither of those last two is currently working for me, but more on that later. Encouraged by Frank's email, I set out to explore further and came across a 2019 European GNU Radio Days workshop, which discussed some of the tools that are available for the PlutoSDR, accompanied by 2 PDF documents walking you through the experience. One comment around why the PlutoSDR uses networking as one of the connectivity options spoke to me. From a usability perspective, networking makes it easier to access the PlutoSDR from a virtual machine, since most of the time that already has network connectivity, whereas USB often requires drivers. As you might recall, network connectivity is one of the many things that I'm trying to achieve with a project that I'm calling Bald Yak, since by the time we're done there's not going to be much hair left from all the yak shaving. The Bald Yak project aims to create a modular, bidirectional and distributed signal processing and control system that leverages GNU radio. As a result, I set about trying to actually walk myself through those PDF tutorials, and got stuck on the first sentence on the first page, which helpfully states, quote, "The necessary prerequisites have been installed on the local lab machine," end quote. It went on to supply a link to a page with instructions on how to acquire those very same prerequisites. 2 days later, after much trial and error, I can now report that I too have these installed, and because I cannot help myself, I made it into a Docker container and published this on my VK6 FLAB GitHub page. To put it mildly, there's a few moving parts and plenty of gotchas. As an aside, if you think that installing Docker is harder than installing these tools, I have some news for you. Trust me, by a long shot, it's not. Right now, I'm working on writing the documentation that accompanies this project, such that you can actually use it without needing to bang your head against the desk in frustration. Mind you, the documentation part of this is non-trivial. For reasons I don't yet understand, my Pluto does not want to talk to the network directly over either Wi-Fi or Ethernet, and connecting over USB through a virtual machine inside a Docker container is giving me headaches. So right now I'm connected across the network to a Raspberry Pi that's physically connected to the Pluto. As a result, I can now use the tools inside my Docker container connected to the Pluto through the Pi, and if you're curious, IIoD is the tool to make that happen. More documentation. At this point you might well ask, why bother? This is a fair question. Let me see if I can give you an answer that will satisfy. Monitoring solar flux typically occurs at 2.8 GHz, which is outside the range of RTL SDR dongles, which top out at about 1.7 GHz. For the PlutoSDR, however, it's almost perfectly within the standard frequency range. One of the tools that is introduced by the talk is an application called IIO-Scope, which, as the name suggests, is an oscilloscope for IIO, or industrial I/O devices, of which the PlutoSDR is one. As an aside, the accelerometer in your laptop, the battery voltage, the CPU temperatures, fans, and plenty of others are all IIO devices that you can look at with various tools. So once I finish the tutorials, I suspect that I will understand a little better how some of the various parts of the PlutoSDR hang together, and I can set it up to monitor 2.8 GHz. Of course, that's only step 1. The next step is to make a Raspberry Pi record the power levels over time. Better still, record it on the PlutoSDR itself, and see if we can actually notice any change, without requiring anything fancy, like a special antenna, some massive filters, a special mount, and all the other fun and games that no doubt will reveal themselves in good time. It also means that, if I got this right, I have the beginnings of the bits needed to get the PlutoSDR to talk to GNU radio. Why? Because I can, and because Frank asked. Also, yak shaving. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.